When we picture the solar system, we usually imagine a crowded diorama of planets rotating shoulder to shoulder around the sun. In reality, stepping off a planet means entering an immediate, silent void. The solid matter is swallowed completely by the dark. This geometric diagram maps the perceived size of our star from different orbits. Because Mercury sits so close to the center, you might expect the sun to dominate its entire horizon. But from the surface of Mercury, the sun only appears 3 times larger than it does from Earth. The spaces between the orbits are staggeringly wide. If you leave the inner rocky planets and travel outward to the gas giants, the distance between Mars and Jupiter stretches out across hundreds of millions of kilometers of absolutely nothing. The defining physical characteristic of our local neighborhood is not the matter within it, but the persistent, silent emptiness separating the planets. This historical photograph of Robert Wadlow, juxtaposed against a standard measuring tape, highlights a biological limitation. We evolved to hunt and build at the scale of a few meters. Our primate brains are optimized for distances we can physically walk. To process cosmic distances, we have to abandon our spatial intuition and rely entirely on the mathematics of orders of magnitude, simply adding zeros to a number to jump scale. Relying on human visual instincts for anything larger than our own planet will result in a skewed perception of cosmic scale. These expanding vector spheres illustrate the baseline scale of our immediate reality. Jupiter is roughly 11 times wider than Earth. The Sun is 10 times wider than Jupiter. But against the hypergiant star UY Scuti, our Sun registers as a microscopic speck. UY Scuti's radius is roughly 185,300 times that of Earth. Because volume scales with the cube of the radius, you would need approximately 6.3 billion Earths to fill this single star. If you placed UY Scuti in the center of our solar system, its physical boundary would stretch past Mars. The entire inner solar system would orbit inside the star itself. Stars of this mass defy our concept of solid objects. Their outer layers are essentially a hot, glowing near vacuum. The gravity from the core is barely strong enough to hold on to the gas at the extreme edges. Extreme mass paradoxically destroys physical definition. The largest objects in the universe do not have hard borders. They simply blur vaguely into the surrounding void. Moving up the mass scale brings us to Phoenix A star, a massive black hole anchoring the center of a distant galaxy cluster. Its mass is so high that it tests the limits of how we compare celestial bodies. It represents a concentration of gravity that swallows entire star systems without a trace. When physicists calculated its mass, the numbers exceeded the theoretical limit for how heavy a black hole was supposed to get. They had to refine their mathematical models and introduce new mass classifications just to account for its existence. The cosmos actively produces entities so dense, they demand a reevaluation of the limits of physical matter. If we zoom out past supermassive black holes and massive galaxies like IC 1101, we reach the scale of the intergalactic web. This 3D scatterplot of galaxy filaments highlights a striking structure. Between the threads of light are massive pockets of negative space. The Bootes void is a spherical region 330 million light-years across. The giant void spans 1.3 billion light-years. According to the expected density of the universe, these regions should contain tens of thousands of galaxies. Instead, those filaments disappear, and we find a lack of matter. They are almost perfectly empty. The ultimate defining feature of the universe is not the massive monsters within it, but an unfathomable, quiet nothingness. The observable universe stretches across an expanse of 10 to the 27th meters. That is a 1 followed by 27 zeros. On this scale, the Earth is a mathematical rounding error. The sudden deletion of our planet, our entire biology, and all of human history would not register in the physics of the cosmos. The total physical mass of humanity compared to the universe is equivalent to a fraction of a subatomic quark resting on a single grain of dirt. We inhabit a spatial scale that renders us physically non-existent. Yet, despite our absolute physical insignificance, human intellect managed to navigate this scale. This geometric visualization shows our beginning. Eratosthenes measured shadow angles in 2 Egyptian cities to calculate the planet's radius. Later, Kepler tracked Mars's orbit. Using Mars as a fixed point while Earth moved, he triangulated the solar system's distances without leaving the ground. These calculations formed the base of the cosmic distance ladder, a chain of mathematical reasoning that allowed a tiny species of primates to measure the unmeasurable. Humanity is the mechanism the universe uses to measure itself. When we look up into that featureless sky, we look back with the exact dimensions of the dark.